I'd like to share some engineering rules of thumb and ways of looking at structural components in the interest of creating efficient designs. The goal is to make a part that suits its purpose, is lightweight, and can be reasonably manufactured and assembled. Let's imagine we're looking at this chair design. First, what are the loads and how are they applied? Here, it's hundreds of pounds, straight down. Second, where is the force resolved? In this case, reaction forces from the floor do the job, with roughly equal forces on each leg. Finally, what path does the load take from where it is applied to where it's resolved? We see here that the forces are handled initially by the seat, which has braces to transfer the load to the corners where the legs are. Finally, the legs are pretty much straight down to the floor. Not terrible. But we have to consider non-standard but foreseeable load cases where failure would still be unacceptable. What about leaning back on two legs, which has at least three unpleasant effects? First, forces are doubled with only two legs on the floor. Second, bending. With the reaction force straight up and the leg angled, a bending moment is introduced on the rear legs. Third, stress concentration. The leg is pretty much the same shape and strength along its length and is suddenly braced quite rigidly to the seat frame. The parts of the leg closer to the load see less stress, and it's maximized at the point where the leg is fixed to the seat, because the bending force has the most leverage there. Rule number one is no bending. As a reminder, think about how much you can stretch a stick versus how much deflection you can get if you bend it. Avoid bending and your structure will be far more rigid. Come up with various ways to reduce localized stress and minimize bending. In this case, maybe adding various braces or gussets could reduce the peak stress enough that the entire structure could be made lighter with the same load rating. In the real world, the loads are not ideal, and you can get racking, twisting, or off-axis loads that may be small in comparison to the main design load, but still need to be resolved. In summary, consider the loads and how they flow through the part. Remember that a strong enough part can still be unsuitable if it deflects too much. Strive for a simple shape that experiences fairly even stress, avoiding concentrated weak zones and thick areas that add little to the structure. Finally, you want to be able to make and install the part with the least fuss possible.